Hi guys, welcome to Naresh IT Technologies. This is Subba Raju. We'll see another video session with Unix file permissions. What is a permission? Is nothing but accessibility. In the Unix operating system, to access a file, every user should have some permissions. By default, what are the permissions available? And these permissions, how we are going to view, we can try to see. First, we can able to create a file, cat, I am creating a file, Naresh Technologies. Once you created, hit the return key and type some lines, Control plus D, save and exit. Once you clicked on the save and exit buttons, then prompt will come as usual, ls-l. Hit the command, long listing format will be displayed. In this long listing format, you can able to find the following list of permissions. First one, hyphen, rw hyphen. Next one, rw hyphen. Next one, r hyphen hyphen. First hyphen come to type of the file. Type of the file. Regular file always indicates with hyphen. First three permissions come to owner or user. Second three permission come to group. Third three permissions are coming to others. So total 9 permissions are presented in front of you. First one is hyphen, type of the file. Second 3 is nothing but owner or user indicating with U character. Group indicating with G character. Others indicating with O character. Now R means read, W means write. Hyphen means no permission. R means read, W means write, hyphen no permission. R read, no permission, no permission. Now these permissions contains 3 users. These 3 users means users plus group plus others is equal to, we are calling as all. All users indicated with a letter. This is by default. Whenever you create a file, these permissions existed. Now here X available, R already I said, W I said, hyphen I said, X means execute. These are the permissions available. These are the users available. But how many modes available? These file modes also we can try to observe. These permission modes are classified into 2 types. Number 1, symbolic mode. Second one, absolute mode. Symbolic mode, absolute mode. First, we'll observe symbolic mode. This mode completely working based on symbols or notations. What are the notations commonly we are using here? Plus adding permissions. Adding permissions minus removing permissions equal to assigning permissions or setting permissions. These are the 3 common symbols we are using with symbolic mode. And commonly used command is chmod, stands for change mode. Using this command, we can able to change file permissions. Whatever the permissions we required, we can transfer from one user to another user also. But chmod stands for only change mode. These change mode command syntax and other things we'll see one by one practically. Yeah, we can view that practically, the chmod. I am creating first one file. File name is my file, I said, and I am printing it is my text file. Enter as many lines you want. ls-l. Whenever you are seeing this one, they are giving by default permissions. First hyphen, as I explained, normal file, rw hyphen, rw hyphen, or hyphen hyphen. These are the default permissions available with every created file. Now, we'll try to monitor this using chmod, change mode. For more information, man change mode, online help, change file mode bits, chmod, option, mode, file name. Several options available and you can view here. Changes, no, preserve, root. Like this, different options available. View all these options, -v or -verbose. Output a diagnostic for every file processed. We'll see these options also. Clear. And ls-l, symbolic mode, plus, minus, equal. We'll write a command to remove read permission from owner of the file. chmod, owner means letter U, removing means minus, permission R, file name my file. Press enter. ls-l, owner doesn't have any read permission. Cat and try to display my file. Permission denied because read permission is not there. I want to add read permission from the owner. I want to add read permission to owner, removing write permission from owner and group. chmod, add read permission to owner, comma, removing write permission from owner, adding write permission to group, G plus W, my file. Press enter. ls-l, read permission added. If I able to view that file, yes, it is visible. But if I able to append means unable to, because write permission is not existed. Now, I am going to add write permission to the owner, no permission to the others. chmod, write permission to the owner U plus W, comma, no permission to the others means you need to O minus R. Actually, you need to write RWX, but RWX already absent. No need to present, no need to remove again. So, my file. So, it is adding write permission to user, removing write permission from others. ls-l. Here, who is owner? Who created the file? What is group? In which module or in which project level collection of people using, those members are comes under one group. Who are others? Other than my project or my module people are using, those are comes under others. So, 3 users. All these users we are calling as A, all. I used already minus, I used already plus. I want to use assign. chmod, I want to use U is equal to execute. And I say my file. If I press enter, user assigning with execute permission, ls-l, file automatically converting into green. That itself indicating this file is executable file and this is available, my file. Now chmod or O is equal to, I am giving rwx, my file. O means others. I am assigning read, write, execute permission. Press enter. ls -l rwx. Like this, equal to sign we can use. Plus sign we can use. Minus sign we can use. Symbolic mode completely working based on symbols. I want to remove all permissions from all users. chmod a minus rwx, my file. Perfect command actually. But in this situation, A is not suitable because already this user is there, read write not available, and here execute not available. Better individually removing. If you are using A minus also, it is removing completely. No user having no permission. Perfectly you want to write means you can write chmod as per above permissions I am seeing and I am writing, and already available. Execute only. So u minus execute, g minus rw, and o minus rwx, my file. As per the permissions means this is correct. Same output will be displayed. Better we are using A is nothing but all permission. All users, all permissions removing rwx. This is completely symbolic based. We observed already symbolic mode practically. Now we can see absolute mode in detail. Absolute mode principle is octal number system principle. Means it is following 0 to 7 numbers. These 7 numbers are indicating file permissions. First we will try to see absolute mode principle. Here 1 indicates permission on, 0 indicates permission off. Based on this principle, octal number system is working. As I said, octal number system 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. Now by default, whatever the file permissions available, we know already that. What that one? rw hyphen, rw hyphen, r hyphen hyphen. These are the by default permissions when you create a Unix file. Read 1, write 1, no permission 0. Read 1, write 1, no permission 0. Read 1, no permission 0, no permission 0. All these are comes under binary numbers. These binary numbers will try to convert into octal format. Then we are getting octal number system principle, how it is working. Let we convert the first one. First one is nothing but 1 or 1. 1, 1, 0 to the base 2 is there. This one will try to convert into octal number system principle. 1, 1, 0. Available here base 2. Then once we are going to provide the solution 1, 1, 0. This 2 you are applying starting from 0 onwards. You are converting 1 into 2 square plus 1 into 2 to the power of 1 plus 0 into 2 to the power of 0. 1 into 4 plus 1 into 2 plus 0 into 1. And you can say 4 plus 2 plus 0. So overall you are getting 6 octal number system you are getting. So whenever you are getting that one 1, 1, 0. So it indicates read write permissions. Again also 1, 1, 0 available. So same. Next one 1, 0, 0 available. 2. So 2 available. So we are writing 1 into 2 to the power of 2 plus 0 into 2 to the power of 1, 0 into 2 to the power of 0. 1 into 4 plus 0 into 2 plus 0 into 1. 4 plus 0 plus 0. So 4 is an octal number system. For 4 we are writing only read. So this is the conversion we are doing, one number system to another one. Next, 0 available. If you are converting into binary, 0 represents triple zeros. RWX, no read, no write, no execute. Then you can say no permission. Next, 1 binary number is equal to 001. RWX, no read, no write, only execute. Next, 3 binary number we can see. 3 binary number is 011. RWX, no read, only write and execute. Write and execute. 4 we can view, the 4 we can see. This is read. 4 already completed. 2 we can see. 2 means 010. RWX, no read, no execute, only write. Next, 5 we can see. 5 means 101. That is a 5. Now we can view that one. RWX, no write, only read, execute. Read, execute. Finally, 7. 7 means 111. RWX, read available, write available, execute available. Read, write, execute. 3 permissions available here. So 0 no permission, 1 execute, 2 write, 3 write execute, 4 read, 5th read and execute, 6 read write, 7 read write execute. So perfectly we converted into octal number system all permissions. These permissions practically we can try to apply on the system one by one we can view. We'll observe practically this absolute mode. As I shown already very clearly to you, 0 to 7. 0 means no permission, 1 means execute permission, 2 means write permission, like that one by one we can try to observe. I am creating first a file. File name is naked and I am entering. It is a text file, NF control D, ls-l by default permissions. Now I want to remove read permission from the owner using absolute mode, octal number system principle. chmod, I want to remove read permission from owner of the file, or I want to add some permission, anyone. Completely we need to use here only numbers 0 to 7. You want to remove means we should not use any plus, any minus, any equal to. So to work with that one, removing read permission, I am giving simply 0. 0 means no permission. Write already available, but why you are removing existed permission? But your condition is not there, write must not be removed. Read, remove. Okay, 0 means I am making that one. And remaining permissions, read, write means 6. Only read means 4. I am giving NACRE. I am hitting the return key ls-l. Now these are the permissions it's showing. Now cat NACRE owner, or you are able to append, because the related permissions removed. You want to add same number system we need to follow. I am throwing a question to you. Add read write permission to owner, no permission to group, no permission to others. Let's we'll see answer. chmod Read write permission to owner 6. No permission to group, no permission to others, and file name present ls-l. Now owner can able to view, owner can able to naked append. I am appending naked file, Control D. So this is simply adding as well as removing. But the next question is, write a command, add execute permission to owner, read permission to group and others. Do not disturb existing permissions. We'll see that command. chmod add execute permission to owner 1, read permission to group 4, read permission to others 4. But I said do not disturb existing permissions, means you need to change that one 7. And file name ls-l. Already read double existed, means read write available, execute added, read added. So whenever you don't want disturb existing permissions, check the number which is related to that. I want to add all execute permission to all users, only execute chmod 111 NACRE, only execute. So compare to symbolic mode, absolute mode is simple, clear. Maximum in the real time industry we are using octal number system principle, file permissions. Thank you for watching my videos. For more videos, log in into youtube.com/NareshIT.